A recent study asked 250 randomly selected high school students whether they prefer online classes over in-person classes. Out of the 250 students surveyed, 135 said they prefer online classes. So we have a sample here that is 250 people big, and 135 of the people said they prefer an online class. Say we want to find an interval that contains the actual proportion of students. What we're going to need to do is we're going to want to find a one sample z interval for a population proportion. And what this z is basically saying, we're going to take from a normal distribution and we're going to predict the lower bound and upper bound of this interval using the z interval. What I like to do for these problems is use a method called the 4 C's. That stands for choose, check, calculate, and conclude. So first, we have to start with choose. We already sort of chose a one sample z interval, but now we're going to need to define the parameter of interest. So that's going to be p. P is going to equal the true population proportion for students that prefer online classes. Next, we're going to need to do some checks. Why are we going to need to do these? To make sure that this test is actually going to find an interval that we can make generalizations about. So for the first check that we have to do, we're going to have to make a check to see if it is truly a random selection. And we want to make a random selection to make sure that p hat, the statistics that we got, is a point estimate for the actual population proportion. So up here, we can see randomly stated high school students surveyed. So what we can say now is that problem stated that we already got a random sample. That's one of the 3 checks we need. The second check is a 10% check. This makes sure that when sampling without replacement, we have independence. So the 10% states that the sample size must be less than 10% of the entire population proportion. So at this high school, we can assume 250 is less than 10%. Generally, there's over thousands of people in a high school. It's less than 10% of all students at this high school. So now we have one more check. And that check is going to be the large counts. This makes sure that we have a normal sampling distribution for the z-score so that we can generalize the standard error to a certain degree. So we want a 95% confidence level that we have an interval that will capture the true population proportion. So for large counts, we're going to take n times p hat and n times 1 minus p hat. So what exactly is p hat? P hat is the statistic that we found. So that's going to equal 135 students who said that they prefer online classes over 250 students that were sampled. And this equals 0.54. So now we can find our large counts conditions. So the first, n times p hat equals 250 times 0.54, and n times 1 minus p hat equals 250 times 0.46. So since both of these are greater than 10, we can say the sampling distribution is approximately normal. So now all of our checks have passed. Now we can move on to the calculations. The formula that we need to use to find the interval is p hat, that's that statistic we found earlier, plus or minus z star, I'll go over that in a minute, times the standard deviation, which is p hat times 1 minus p hat over n. P hat is 0.54 times 0.46 over 250. That's how many people we have. But what is this z-star? Z-star is going to be our z-score that we're multiplying the standard deviation by. So to get that, we can go over here into Desmos. We can find a normal distribution, because we found with the large counts that the sampling distribution is normal. Click on bounds. We are going to want to find a 95% confidence interval. So in here, we'll type 0.95 to find 95%, and our z star is going to be this number here, 1.96. So if we go back over, we can do plus or minus 1.96. So what does this actually equal? If we go back to Desmos, do square root 0.54 times 0.46 over n, which is 250. So this is our standard deviation, and then we multiply that by 1.96. This number is going to be how far from the statistic that our interval is going to be. So our statistic is 0.54, and we'll do plus a and minus a. Now we have two numbers, and these are going to be the bounds of our interval. So the lower bound is going to be 0.478. So we go back here, we write lower bound is 0.478, and the upper bound is going to be 0.602. So now we have a 95% confidence interval. But what does this actually mean? For the last step in solving these problems, we have to conclude. We are 95% that the interval 0.478 to 0.602 captures the true proportion of students who prefer online classes. We've solved part A of the problem, which was construct a 95% confidence interval for the proportion of high school students who prefer online classes. The school administration claims that 60% of all high school students prefer online classes. Use the results from Part A to determine whether there is convincing evidence to dispute the administration's claim at the 0.5 significance level. We are going to be using a test to find a p-level. Steps that we did aren't going to change, but for the choose, we are going to want to say one sample z test. And what comes with that is having hypotheses. Basically, this is saying whether you think what they said is true or if it's not. So our null hypothesis, which is what we think is if nothing happened, is that the proportion of students who want to take online classes is equal to 0.6. Our alternate hypothesis is that the probability is not equal to 0.6. We are going to go over to Desmos, go to the addition sign, Inference, and we're going to want to use a z-test for proportions. Our successes from the original problem were 135 successes out of 250 people. So here we have a significance test. For our null hypothesis, we're going to endpoint that 0.6, and we are going to use a two-tailed test. This means that we're going to find the probability that it's greater than 0.6 and less than. Our z-score is equal to 0.1936, and the p-value is equal to 0.053. So now we can go back here. We need to say that the z-score is equal to 1.936, and the p-value that we got is equal to 0.053. When we want to conclude this, we have to include three parts: whether we accept or reject the null hypothesis, the p-value, and what we have convincing evidence of or not. We are going to say, since the p-value equals 0.053, say it's greater than the alpha value, which equals 0.05, which is this 0.05 significance level. We fail to reject the null hypothesis. And now what we need to say is we did not find convincing evidence that the administration's claim is false. So we found no convincing evidence. Explain your reasoning based on the confidence interval. So now we can go back, and our confidence interval was 0.478 to 0.602. What we can say is that since the value 0.6 is in the interval, there's not convincing evidence that they're lying. And that is all that we need for part B.